Alrighty, we are starting a new chapter on something called conic sections. So I'm going to break this video or this lesson apart into two separate videos, but this first one is just going to kind of go over what the basics of them are and 3 out of the 4 types. So we have conic sections. Basically what that means is we're taking a cone. You see the cone here. This is our cone. We're taking the cone and kind of slicing it. So each of the red pictures in our cones here is a conic section. The first is probably the most recognizable, the circle. It's where you take a cone and you slice it parallel to the base, meaning this slice is parallel to our base here. So this here would be a circle. It's a type of conic section. The second one would be down here. You may refer to it as an oval. The mathematical term for it is an ellipse. And basically the only difference between a circle and an ellipse is rather than slicing the cone parallel to the base, you're just slicing in a way that is not parallel to the base. So you get kind of this oblong shape to it. The third type is the one we're already the most familiar with. It's where we slice, but we actually end up hitting the base as we're slicing here. So we end up with this kind of U shape, which you should already know is called a parabola. The final type, probably the most interesting, that we'll spend not as much time on, is over here, where when I'm slicing, I'm going at an angle and hitting both parts of the cone, the top and the bottom. So I get these 2 U shapes, the bottom and at the top here. This is called a hyperbola. Now, you should have gotten this sheet when you walked in. If you did not, go over to the door, and it's sitting on the little shelf right inside the door there, and it should have 2 sides. We'll start with circles because they're the most familiar to us. Now, when we're talking about circles, you should already know kind of what they are. Now, in a circle, there's actually a very specific mathematical definition reference here. So a circle is a set of points that is equidistant from the same fixed point. Now, that's a very mathy way of saying that a circle is made up of a radius and a center. A set of points that are equidistant, meaning they're all the same distance away from, is referencing our radius. The same fixed point referencing the center. So we already know that in a circle, kind of like how this is set up, there's a center, and all the points are the same r distance away from the center. Now, that becomes super handy when we start to talk about how to graph these. So we're going to talk about 2 different equation forms during this chapter in each of the 4 different types of figures we're talking about. So there's going to be what we call a graphing form and a standard form. Now, graphing form looks like this. Now, most of those letters should look very familiar to us. H and K, we already know what those are. The only new letter here really is R. Now, based off of our context clues here, I would assume that you know what R is. That's right, if you just said to yourself in your head that this is the radius, you would be correct. R references the radius, and in this case, H and K, just like how in our parabola it referenced the center of the parabola, the vertex, it references the center of the circle. Now, standard form looks just a tiny bit different. So it's the same letters, just kind of reorganized in a slightly different fashion. yes, that is a minus sign there in between the y and the k. So in this case, our center of our circle is at hk with a radius of r. So basically what we're going to be doing throughout this chapter is graphing things using those two formats. So I'm going to give you an example of what I mean. So something like x minus 2 squared plus y minus 5 squared equals 16. So in this case, looking at our equation, we can find our center would be at 2 and 5. Now that's a slight change from what we're used to because this is now opposite. The reason being the y minus k you see in the equation, and our radius here is not 256. It's actually 4, because what we're looking for is what number squared would make this number. So when I graph, we're going to have kind of a certain set of steps for graphing. Step number 1 is going to be to find your center. Now the center is not technically part of the graph. I always put it on there because it just makes it a little easier for me to figure out where I'm going. So 2, 5. Then you use your radius to go up, down, left, right from your center. So up, down, left, and right from your center. Then from there, you connect to make a circle. Now, as long as it's not a diamond, you're going to be fine. So as best you can to make kind of a circular shape here that's kind of diamondy. That would be our circle. Now I could ask you to graph, or I could ask you to use the information given to work backwards to create an equation. So maybe I say, for example, so this is example 1 up here. Maybe for example 2, I ask you to create the equation based off of some information. So something like you have a center of -1, -3, a radius of 5, and you have to create the equation. Well, we know h and k, we know r, we're just going to plug them in. Now it does not matter if you plug them into standard form or graphing form, as long as you plug them in. So x minus a -1, which is +1, and then y minus a -3, which is +3, equals our radius squared. You could put either 5 squared or 25 and you would be absolutely correct. So if we were to create this -1, 3, we go out 5 in each direction. 1, there, there, and there. And then you just do your best to make a circle that would connect to those points. So that's basically circles. Now, I put a cone on here for you so that you'd be able to kind of draw what part of the cone we're talking about. We're talking about slicing parallel to the base. Now, we're not going to spend a ton of time on ellipses right away, so we'll kind of reference this later, but it's set up very similar to circles. In fact, so similar that the equations just have one minor difference between the two. So if I'm going to put in standard and graphing form, our standard form equation would be this. Now, if you're flipping back and forth and kind of referencing the two, notice the difference here. So this one has an r squared at the end and nothing in front of the parentheses. This one has that r showing up in front of the parentheses and a 1 at the end. Now, these two r values are very important. Basically, what they're going to tell us is how wide does our shape go in either direction, meaning this radius references how far our ellipse is going to go side to side, and this one is going to reference up and down. So I'm going to pause here and move on to our next video.